Welcome to in-depth discussion of JEE Mantra Test Series test number 3. In this video, we will be discussing all the questions from the subject physics. Here comes the first question. The question says, a convex mirror of radius of curvature 30 centimeter forms an image that is half the size of the object. Half the size of the object, then the object distance is. All right. So here m is equal to 1 by 2. M is equal to 1 by 2. All right. Then radius of curvature r. What is r value? R value is 30 centimeter. And what we want is, we want the value of object distance, that is u. So that is the question. Clear? We all know that 1 by v plus 1 by u equals 1 by f. Let me multiply this entire term, this entire equation with u. Then u by v plus, here this is going to be 1, that is equal to what? U by f. Okay. So from here I can say that u by v, that is equal to u by f minus of 1. All right. Or u by v, that is equal to u minus of f all divided by f. Now, what is the expression for magnification in case of a spherical reflecting surface? M is equal to minus of v by u, isn't it? So considering this, I can say that m is equal to minus of v by u, okay, is equal to, here this is going to be what? F upon f minus u. And we know the value of m. What is m? M is 1 by 2. All right, m is 1 by 2. So 1 by 2 equals f divided by f minus u. Fine. Now, we know that r, that is equal to what? 30. R is given as 30 centimeter. All right, 30 centimeter. So f need to be what? F need to be 15 centimeter. Okay, thus substituting that value over here, I can say that 1 by 2, that is equal to 15 divided by 15 minus of small letter u. Rearranging this, 15 minus u, okay, 15 minus u, that is equal to what? 30. This 15 into 2, that will give 30. So from here I can say that minus of u, that is equal to 30 minus of 15, that is 15. So value of u is coming as minus of 15 centimeter, which means option A must be the correct answer in this case. Moving to the next, question number 2. A biconvex lens of refractive index 1.5 has a focal length of 20 centimeter in air. That's important, in air. If the its focal length when immersed in a liquid of refractive index 1.6 will be. We know the general expression 1 by f, that is equal to mu2 divided by mu1 minus of 1 into 1 by r1 minus 1 by r2. This is general expression. Okay. Now, this part is constant in both the case. Okay, so I will be replacing 1 by r1 minus 1 by r2 by k. So here this is going to be 1 by f, that is equal to mu2 divided by mu1 minus of 1 into k. Okay, now, so this is my general expression, modified general expression. This is my modified general expression. Is that okay? Fine. Now, have a look. In first case, mu2. In first case, mu2 is what? Mu2 is 1.5 and mu1 is 1 because it's in air. In second case, mu2 is 1.5 and mu1 is 1.6. So I can write the expression as 1 by f1, that is equal to, I told you mu2 is 1.5. Okay, divided by mu1 is 1 minus of 1 into k. And for the second one, it is 1 by f2 equals 1.5 divided by 1.6 minus of 1 into k. All right, here this is equation number 1 and here this is equation number 2, equation number 1 and 2. Now let me divide this. So here this is going to be f2 by f1. I mean I am dividing equation number 1 with equation number 2. So here this is f2 upon f1, that is going to be, here I am going to get this as 0.5 all divided by, here it is going to be 1.5 minus 1.6, that is 0.1 into 1.6, isn't it? Now let me rearrange the expressions. Now f2, that is going to be f1 into, here this is 0.5 into 1.6 all divided by, okay, all divided by one second, I think 1.5, here this need to be minus of 1, this need to be minus of 1, isn't it? Because 1.5 minus of 1.6, that is minus of 0.1. All right, so here f2 minus f1, that is f1 into 0.5 into 1.6 all divided by minus of 0.1. Okay, now f2 equals, what is f1? f1 was 20 centimeter. So 20 centimeter into, here this is 0.5 into 1.6 all divided by minus of 0.1. Okay, so here this is minus of 20 into, here this is 5 into 1.6 centimeter, minus of 20 into 5 into 1.6. So here you know that here this is going to be what, 100. All right, so here you will get the value of f2 as minus of, here this is 100, so here this is going to be 160. So the answer is minus of 160 centimeter. Now let me compare with the options here. That means option B need to be the correct answer in this case. Next is question number 3. Question number 3 says, if the distance between object and its 2-time magnified virtual image produced by a curved mirror is 15 centimeter, then the focal length of the mirror must be. So here the image formed is virtual and it is 2 times magnified. That means here we are going to have a case of what, concave mirror only. All right, it's going to be a concave mirror and the object need to be placed between F and P. All right, so here this is A, B, and this need to be what, A dash, B dash. All right, so I can mark this as U and I can mark this as what, V. So the magnitude of U plus V, I repeat, magnitude of U plus V, that is equal to how much? It's marked as 15 centimeter. This much is equal to 15 centimeter, isn't it? Now magnification M, that's equal to what, plus 2. It's erect, isn't it? And double the size, that's why I'm marking it as what, plus 2. So we know that M, that's equal to minus of V by U, minus of V by U. V is towards the left and U is towards right. Fine. So from here I can say that 2 is equal to V by U, or 2 times U is equal to what, V. 2 times U is equal to what, V. Fine. Now we know that 1 by V plus 1 by U, that is equal to 1 by F. Okay, now here we have got a relation, V plus U is equal to what, 15. So U plus, what was V? V was 2 times U. 2 times U is equal to 15. That means 3 times U, that's equal to what, 15, which means U is equal to what, 5. U is equal to 5. Now I am going to use this information here. Okay, 1 upon V. V is towards right, so that's going to be positive, and V is what? 2 times U. So this is plus 10. 1 upon 10 plus 1 upon, what is U? U is towards left. That's why this is need to be minus of 5. That should be equal to what? 1 by F. Okay. Now, rearranging this expression, I can say that 1 by 10 minus of 2 by 10, that's equal to 1 by F. Nothing, multiplying this with 2 and dividing with 2. That's all. So here this is going to be 1 minus 2 is minus of 1 by 10 equal to 1 by F. So F is equal to minus of 10, which means option C need to be the correct answer. All the measurements are in centimeter. All right. So that's by default, it's clear. Moving to the next, that is question number 4. Question number 4 says, the refractive index of a prism with apex angle is cot of A by 2. Then the angle of minimum deviation is. We know the general expression mu equals sine of A plus dou minimum by 2 upon sine of A by 2. This is general expression. And it is given that mu equals cot of A by 2. Cot of A by 2 means cos of A by 2 upon sine of A by 2. That is cot of A by 2. That is now equal to sine of A plus dou minimum by 2 upon sine of A by 2. These two will get cancelled each other. Cos of A by 2 can be written as sine of pi by 2 minus A by 2, and that is equal to sine of A plus dou minimum by 2. Solving this ahead, I can say that pi by 2 minus of A by 2, that is equal to A by 2 plus dou minimum by 2. Here 1 by 2 will get cancelled from all the sides, isn't it? Now solving this ahead, pi minus of, I have got an A here, taking this towards the left. Here this is going to be 2 times A. That's going to be dou minimum. So basically dou minimum, that's equal to pi minus of 2 times A. I repeat, it is pi minus of 2 times A. That means 180 degree minus of 2 times A. That means option D must be the correct answer in that case. Next is question number 5. Here comes question number 5. Light rays from an object have been reflected towards an observer from a standard flat mirror. The image observed by the observer are. First one is option says it's real. Second one says that it's going to be erect. Third option says that smaller in size than the object, laterally inverted. Okay, so the image formed by the plane mirror, that is never a real, that's virtual image. It's going to be erect and there is no change in the size. So this option is wrong. And obviously we know that, I mean, in the recap video I said, if I am having an object like this, the image is going to be in this way. So here this is lateral inversion. So lateral inversion is also there. That means statement number 2, I mean B as well as D need to be the correct answer. That means B and D, which means option A must be the correct answer in that case. Moving to the next, that is question number 6. Question 6 says, a person has been using a spectacle of power minus of 1 diopter for distant vision and a separate reading glass of power 2 diopter. Okay, so the reading glass is of 2 diopter. What is the least distance of distinct vision for a healthy human being? All right, I mean the one who has got a healthy eye, the least distance of distinct vision need to be 25. Okay, so if it is not so, all right, that means if there is a change in least distance of distinct vision, that means any object which is at least distance of distinct vision need to be taken to the changed least distance of distinct vision. That means the image need to be formed, the image of the object, that is actually kept at least distance of distinct division need to be taken to the new point, new least distance of distinct division. All right. So here we are using a lens, so that's why I need to write the thin lens formula, that is 1 by V minus 1 by U equal to 1 by F. So here V is going to be the new least distance of distinct division, new least distance of distinct division, and U, that is going to be the original least distance of distinct division. That means an object actually kept at actual value of least distance of distinct division need to be that means that the image of that particular object need to be taken to the new least distance of distinct division, because the eye can identify light coming from the new least distance of distinct division only. That is the concept behind that. Okay, so for us we need to get the value of what? New least distance of distinct division. That means we need to get the value of V. So 1 by V minus of 1 upon minus of 25 centimeter, that need to be equal to what? 1 by F. Okay, we don't know the value of F, but we know the power. What is power? Power is 2, and we know that 1 by F, that's equal to what? 2. That means F is equal to 1 by 2, that means 0.5, that is 50 centimeter. All right, so I will be taking the help of this information here. So 1 by V minus of, all right, minus of minus, that is plus, that is 1 by 25, that is equal to 1 upon 50. Okay, now 1 by V, that is 1 upon 50 minus 1 upon 25. Let me multiply by 2 and divide this with 2. So here 1 by V, that's going to be 1 minus of 2 divided by 50, that is minus of 1 by 50, which means V is equal to what? Minus of 50 centimeter. So the new least distance of distinct division is what? Minus of 50. So I repeat once again, earlier the least distance of distinct division was 20. Now he or she is not able to identify an object which is kept at 25 centimeter. So for any object which is kept at 25 distance, with the help of optical instrument, the image is formed at 50, and the eye is identifying the image which is formed at 50 as the real object. So that is how the vision is enabled for him. All right, moving to the next, that is question number 7. Here comes question number 7. The question says, a thin prism P1 with an angle 6 degree and made of glass of refractive index 1.54 is combined with another prism P2, all right, made of glass of refractive index 1.72, produce dispersion without average deviation. Then the angle of prism P2 is. So basically here the deviation produced by mirror number 1 need to be equal to what? Deviation produced by mirror number 2. So dou 1 need to be equal to what? Dou 2. Okay, we know that dou is equal to mu minus 1 into A. That is a general expression. All right, so comparing this, mu 1 minus of 1 into A1, that need to be equal to what? Mu 2 minus of 1 into A2. All right, fine. What was mu 1? Mu 1 was 1.54. 1.54 minus 1 is 0.54. So 0.54 into A1, that need to be equal to 0.72 into A2. A1 is 6 degree. So here I may write 54 into 6, that is equal to 72 into A2. All right, let me cancel both the terms with 9. So here this is going to be 8, and here this is going to be 6. So here this is 36 equals 8 into A2. If I cancel, if I divide with number 4 on both the sides, here this is going to be 9, and here this is going to be what? 2 into A2. From here I can say that A2 is equal to what? 9 by 2, that means 4.5 degree. 4.5 degree, which means option D must be the correct answer in this case. All right, moving to the next, that is question number 8. Question number 8 says, an object is placed at a distance of 12 centimeter in front of a plane mirror. Okay, in front of a plane mirror. Then the virtual and erect image is formed by the mirror. So fine. So here, let this be the object. All right, which is at a distance of what? 12 centimeter. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So here will be the image. So here this is AB, and here this is A dash, B dash. This is 12, and this one also need to be 12. Okay, here this is the plane mirror. Fine. Now the mirror is moved by 4 centimeter towards the stationary object. So the object remains the same, all right, and the mirror is now moved through 4 centimeter. All right. So here this distance is going to be what? 8 centimeter only. 1, 2, 3, 4. 1, 2, 3, 4. So here this is going to be the image now. So here this is AB. Now here this is A double dash, B double dash. New image. All right. So the thing is, it shifted through this much distance, isn't it? So here this is what? This is going to be 8 centimeter. All right. So the shifting is towards the mirror. It's towards the mirror. Away from the mirror is not in the list even. So earlier the distance between the object and the image, that was 24 centimeter. All right. Now it is 16 centimeter. Here the distance of separation is 16 centimeter. So it got changed through 8 centimeter. So the shifting is through 8 centimeter. So the image got shifted towards the mirror, or I can say shifted towards the object through a distance of 8 centimeter towards the mirror. So answer is 8 centimeter towards the mirror. Option D need to be the correct answer in that case. All right, moving to the next, that is question number 9. When a Polaroid sheet is rotated between two crossed Polaroids means Polaroid number 1 is kept like this, and like here this is y axis, all right, and the second one is kept like this. So this is z axis now, crossed Polaroids. Okay, then the intensity will be maximum 45 degree for sure, no doubt at all. It's a theoretical question. Moving to the next, that is question number 10. In Young's double slit experiment, light from two identical sources are superimposing on a screen. The path difference between the two lights reaching at a point on the screen is 7 lambda by 4. The ratio of intensity of fringes at this point with respect to the maximum intensity of the fringe is. All right. So the basic expression is intensity I, that need to be 4 times I naught into cos square phi by 2. All right, and maximum intensity I max, that is basically what? 4 times I naught. All right, so this is for any randomly selected point where the phase difference is phi, and here this is the maximum. All right, yes. Now what we have, the path difference delta P is given us how much? 7 lambda by 4. Delta P is given us 7 lambda by 4. We all know that where phase difference is 2 pi, their path difference is what? Lambda. And here the path difference is 7 lambda by 4. So there the phase difference need to be, I repeat, the phase difference need to be 7 lambda by 4 into 2 pi all divided by lambda. Lambda and lambda will cancel each other. So here the phase difference phi, that is going to be what? That is going to be 7 pi by 2. I repeat, 7 pi by 2. Now what about cos of 5 by 2 basically. Cos of 5 by 2 then need to be cos of 5 is 7 pi by 2. So here this is going to be 7 pi by 4. Now, what about cos square 7 pi by 4? That is going to be cos square pi by 4 only. All right, that is what? 1 by root 2, the all square, that is 1 by 2. Okay, so cos square 5 by 2 is 1 by 2. Now let's take the ratio. See, the ratio of intensity of the fringe at this point with respect to the maximum intensity of the fringe. So once I do take the ratio of this one, 4I0 and 4I0 will cancel each other. We are left with cos square 5 by 2 only. And what is the value of cos square 5 by 2? It's 1 by 2, which means the answer is option A. All right. Moving to the next, that is question number 11. Here comes question number 11. The diffraction pattern of a light of wavelength 400 nanometer diffracting from a slit of width 0.2 mm is focused on a focal plane of convex lens of focal length 100 centimeter. The width of the first secondary maximum will be. We know that the expression for width of the secondary maximum, y, that can be written as lambda capital D divided by small letter d. And for the central maximum, this need to be what? 2 times lambda capital D divided by small letter d. All right, our part is this one only. Now, y is equal to, what's the value of lambda? Lambda is given as 400 nanometer. So 400 into 10 to the power minus of 9 into capital D. What is capital D? Capital D is focal length only. That is 100 into 10 to the power minus of 2, all divided by 0.2 mm. I can write this as 2 into 10 to the power minus of 4. All right. Let me deal with this first. So here this is going to be 200. Okay. Now, this will go to the top. So here this is going to be 200 into, once this go to the top, here this is 10 to the power minus of what? 5 into 10 to the power. So here this will cancel each other, isn't it? Now it is 200 into 10 to the power minus 5 only. I repeat, 200 into 10 to the power minus of 5 only, isn't it? So here this is 2 into, if I consider this 2, here this is 2 into 10 to the power minus of 3 meter. Or I can say it is 2 mm. That means option A must be the correct answer in this case. Moving to the next, that is question number 12. When unpolarized light is incident at an angle of 60 degree on a transparent medium from air, the reflected ray is completely polarized. Then the angle of refraction in the medium is. So basically this is polarization by reflection, that is Brester's law. Here this is I suffix p. Here also it need to be what? I suffix p only. And here the angle between these two, that need to be what? 90 degree, and here this is r. You all know that if this is the case, then I plus r, I mean I suffix p plus r, that need to be what? 90 degree. All right, I suffix p is what? 60 degree. So 60 degree plus r, that need to be 90 degree, means r is equal to what? 90 degree minus of 60 degree, that is 30 degree, which means option A must be the correct answer. Next is question number 13. Here comes question number 13. The question says, a monochromatic light of wavelength 6000 angstrom is incident on a single slit of width 0.01 mm. If the diffraction pattern is formed at a focus of convex lens of focal length 20 centimeter, then the linear width of the central maximum is. Just in this case, I already explained the width of the central maximum, isn't it? That is 2 lambda capital D by small letter d. So here again, y of central maximum, that is 2 times lambda capital D divided by small letter d. So here this is 2 into, what is the value of lambda? Lambda is 6000 into 10 to the power minus of 10. Okay, into capital D. Capital D is 20 centimeter. So 20 into 10 to the power minus of 2. All divided by what we have? small letter d as 0.01 mm, isn't it? That is 0.01 into 10 to the power minus of 3. Okay, now let me rearrange this first. So here 6 2s are 12 and 12 2s are 24, isn't it? So here this is 24 into what I have over here. This is 10 to the power 3. All right, here this is 10 to the power 3 and here this is 10 to the power 4. So let me write this as 10 to the power 4 and here this is 10 to the power minus 10, 10 to the power minus 2, that is 10 to the power minus of 12, all divided by, here this is going to be 1 into 10 to the power minus of 5. Okay, so here this will go to the top. So here this is going to be 24 into 10 to the power 4 into 10 to the power, and here this 5 will go to the top. So here this is going to be 10, basically 10 to the power minus of 7 only, isn't it? So now rearranging this, I can say that it is 24 into 10 to the power minus of 3. 24 into 10 to the power minus of 3. That means option B must be the correct answer in this case. Question number 14. The ratio of intensities at 2 points P and Q on the screen in Young's double-slit experiment, where the phase difference between the two waves of same amplitude are pi by 3 and pi by 2 respectively. Okay, so we need to identify basically the ratio of intensity. So what is the general expression? General expression for intensity is 4 times I naught into cos square phi by 2. So here, what is phi 1? Phi 1 is marked as pi by 3 and phi 2, it is marked as pi by 2. Okay, so if I take the ratio I1 by I2, 4 I naught and 4 I naught will cancel. So here this is basically going to be cos square, phi is 5 by 3. So 5 by 2 is going to be what? Pi by 6. All divided by cos square. Here this is pi by 2, isn't it? So half of that is going to be pi by 4. So I can say I1 by I2. I1 by I2. So here this is pi by 6. Pi by 6 means basically it is 180 by 6, that is 30 degree. So cos square 30 all divided by, here this is cos square 45 degree, isn't it? So here this is I1 by I2 is now cos square 30 means cos 30 is root 3 by 2. So cos square 30 is 3 by 4. All right, and here this is 1 by 2. All right, so here this one and this one will cancel each other. We'll leave 2 on the denominator. So finally it is 3 by 2. That means option A must be the correct answer in this case. All right, moving to the next, that is question number 15. The question says, the interference pattern is obtained with two coherent light source of intensity ratio 4:1. All right, and the ratio of I max plus I minimum upon I max minus I minimum is 5 by x. And what is the value of x? That's the question. All right, so the question says I1 by I2, that is equal to 4, isn't it? That means I1 that equal to 4 times I2. Now please tell me, what is the expression for I max? I max that need to be I1 plus I2 plus 2 times root of I1 into I2. That is I max. And what about I minimum? I minimum need to be I1 plus I2 minus of 2 root of I1 into I2. Okay, now let me get the expression for I max first. So Imax is, I have got the expression for I1 as 4I2. I repeat, I1 as 4I2. So here this is going to be 4 times I2. I'm replacing I1 with 4 times I2. Again plus I2 plus 2 into root of 4 times I1 into I1. All right. Sorry. It's 4 times I2 into I2. So here this is 4I2 plus I2. This is 5I2. And here this is going to be what? Here this is going to be 2I2 only. And 2 to the 4. So here this is 4I2 plus here this is 4I2, isn't it? Fine. So here this was 4I2 and here this is 2 to the 4, again 4I2 plus I2. So here this is finally Imax equals 4 plus 4 8 plus 1, it's 9I2. So Imax is what? 9I2. And what about I minimum? I minimum is going to be again 4I2 plus I2, that is 5I2. All right. And here this is going to be minus of what? Here this is again 2 to the 4I2, isn't it? So here I minimum is going to be what? I2. So I max is 9I2 and I minimum is I2. Now have a look. What is the ratio? Here I max plus I minimum upon I max minus of I minimum. We got it as 5 by x. As per the question, this need to be equal to 5 by x. I max is 9I2. I minimum is I2. So here this is going to be what? 10I2. All right. Here this is 9I2 minus I2, that is 8I2. That is 5 by x. Definitely I2 and I2 will cancel each other. All right. So here what we have? The possibilities are these two must cancel each other, isn't it? Now please tell me what is the value of x now? The value of x, that need to be equal to 4. This will go to the right, this will come down. So we will get x as 4. That means option B must be the correct answer. Next is question number 16. The question says, in Young's double slit experiment performed using a monochromatic light of wavelength lambda, when a glass plate of thickness 1.5, glass plate of refractive index 1.5 of thickness x times lambda, okay, is introduced in the path of one of the interfering beam, the intensity at the position where the central maximum occurred previously remained unchanged. Then what is the value of x? What is the value of x? We all know that delta P, that is supposed to be y into small letter d all divided by capital D, isn't it? Fine. So here this is the expression for what? Delta P. Fine. Now once we introduce, I repeat, once we introduce a glass plate of refractive index mu and thickness t, there will be an additional path difference, and that path difference created is delta P dash. That's going to be what? That is going to be mu minus 1 into small letter t. We know about this part. Okay. So in that case, the shift in the fringe, okay, that is delta y, that is supposed to be mu minus 1 into t times capital D all divided by small letter d. Okay. If the central maxima is again appearing on the same point, that means the position of the bright fringe is getting overlapped. That means either the first one got overlapped with the second one, or the second one might have overlapped with the fourth one. That means if this is a bright fringe and here this is dark fringe, and here this is again a bright fringe, and here this is a dark fringe. So either the shifting might be like this, or this must get shift in this manner. That means the shifting is happening in terms of n times the fringe width. That means delta y, that is going to be integral multiple of what? Fringe width only. So here we are getting the expression for what? Delta y. So delta y, that means the shifting, that is mu minus 1, okay, into t capital D all divided by small letter d, that is equal to n times beta. Now please tell me, what is the value of beta? We all know that beta need to be what? Again n times lambda, okay, so sorry, not n times lambda, beta is lambda times capital D all divided by small letter d. So this is expression for what? Beta. So let me substitute that over here. Okay, so now I can say that, so I'm removing this part, let it be there. So once I substitute that, so mu minus 1 into small letter d. What is small letter d? X times lambda. Okay, small letter d is x times lambda into capital D all divided by small letter d. That is n times, what is the expression for beta? Expression for beta is lambda capital D all divided by small letter d. Small letter d and small letter d will cancel, lambda and lambda will cancel, capital D and capital D will cancel. All right, now what we are left with? We are left with the values. As mu minus 1 into x. Mu minus 1 into x, that's equal to what? N. Okay, now what is the value of mu? Mu is 1.5. 1.5 minus 1 is 0.5. 0.5 is 1 by 2. So x by 2, that need to be what? N. X need to be 2 times n. X need to be 2 times n. And what could be the value for n? N is 0, 1, 2, 3, etc. Isn't it? So in considering that, if it is 0, it's 0. So 0 is not there. And if it is 1, that's going to be what? 2. And if it is 3, it's going to be 6. That is not in the option. Okay, and that is the largest value. These two are already eliminated. So option B must be the correct answer in that case. Moving to the next, that is question number 17. Question number 17 says the threshold frequency. The threshold frequency of a metal whose work function is given as phi, that is equal to 6.63 electron volt. All right, we all know that phi, that is what? H into threshold frequency, H into nu. So here this need to be 6.63 into, here this is the energy term, isn't it? So here this is in electron volt, this is in electron volt, so it is 1.6 into 10 to the power minus of 19. That need to be equal to H. H is again 6.63 into 10 to the power minus of 34 into nu naught. All right, 6.3 and 6.3 will cancel each other. Let me take this towards the left. So here this is 16. I'm going to write this as 16 into 10 to the power minus of 20 plus, once this comes to the right, here this is going to be 34. Nu naught is going to. So here I may write this as nu naught, that is equal to 16 into 10 to the power 14 hertz. All right, 16 to 10 to the power 14 hertz. So 16 to 10 to the power 15 is there, so that must not be the option. That means it's going to be 1.6. Nu naught is going to be 1.6 into 10 to the power minus of 15. All right, so 16 into, like I got it as 16 to 10 to the power 14. So here it is, they marked it as 16 to 10 to the power minus 15. So rearranging that, I should get it as 1.6 into 10 to the power 15. 10 to the power 15. All right, moving to the next, that is question number 18. The question says two sources of light emits with a power of 200 watt. So the power coming out is basically the same. Then the ratio of number of photons of visible light emitted by each source having the wavelength as 300 nanometer and 500 nanometer is. So we all know that hc by lambda, that is going to be the what? The energy of one photon. All right. And if n1 number of photons are coming out in 1 second, that means basically the power here, this is going to be what? P1. And n2, and here this need to be what? Lambda 1. All right. Now n2 into hc divided by lambda 2, that is going to be the power for the second radiation. Basically power is the same. That means n1 divided by lambda 1, that need to be what? N2 divided by lambda 2, isn't it? Now they are asking for the value of n1 by n2. So n1 by n2, that need to be what? Lambda 1 divided by lambda 2. Lambda 1 as well as lambda 2, basically they are in given in terms of nanometers. You know, nanometer and nanometer will cancel each other, and it need to be what? 3 by 5. It need to be 3 by 5. That means option D must be the correct answer in that case. Moving to the next, that is question number 19. For the photoelectric effect, the maximum kinetic energy E suffix k of a photoelectron is plotted against the frequency of the incident photon as shown in the figure. The slope of the graph is, so basically it is energy versus frequency graph, isn't it? Energy versus frequency graph. So the slope of that need to be what? Planck's constant. Need to be what? Planck's constant. All right, moving to the next, that is question number 20. The de Broglie wavelength of a proton of an alpha particle are lambda and 2 lambda. All right. Yes. So respectively, then the ratio of velocities of the proton and alpha particle will be, isn't it? So we all know that lambda, that is h upon p. So lambda of p, I mean proton, isn't it? And lambda of alpha particle, that need to be 1 upon mass of proton into velocity of proton multiplied by mass of alpha particle multiplied by velocity of alpha particle. So here the wavelength is given as what? Lambda upon 2 lambda, isn't it? Lambda by 2 times lambda. So this one and this one will cancel each other. So we need to focus on this much part only. So I can write mass of alpha particle into velocity of alpha particle all divided by mass of proton into velocity of proton, that is 1 by 2. All right. Let me rearrange this. Mass of alpha particle is 4 times mass of proton into velocity of alpha particle all divided by mass of proton into velocity of proton, that is going to be 1 by 2. Mass of proton and mass of proton will cancel each other. We need the velocity of proton upon alpha particle. So Vp upon V alpha, this is what we need. Vp upon V alpha, that need to be what? 8 by 1, which means option D must be the correct answer in that case. Next is question number 21. Here comes the question. The question says, two immiscible liquids of refractive indices 8 by 5 and 3 by 2 respectively are put in a beaker as shown in the figure. The height of each column is 6 centimeter. Height of each liquid column is 6 centimeter. A coin is placed at the bottom of the beaker. For near normal vision, the apparent depth of the coin is alpha by 4. Okay, then the value of alpha is. So here the apparent depth, H apparent, it is given as alpha by 4 in centimeters. So here this is basically going to be the apparent depth of liquid number 1 plus apparent depth of liquid number 2. The summation need to be what? Alpha by 4. That is the basic concept. So here this is 6 centimeter. So I can say that 6 upon, what is the refractive index of first liquid? That is 8 by 5. Okay, plus 6 upon, what is the refractive index of the second one? That is 3 by 2. That need to be equal to alpha by 4. All right. So here 6 is common. Let me take that out. So here this is going to be 5 3s are 15, and here this is going to be 8 2s are 5 3s are 15, 8 2s are 16. All divided by 8 3s are 24. That's going to be equal to what? Alpha by 4. All right. So here this is now 6 into, here this is 31, all divided by, here this is 24, and now that is equal to what? Alpha by 4. Okay. Now if I cancel this, here this is what? 6, and 6 will cancel each other. So alpha is equal to what? Alpha equal to 31. Okay, so the value of alpha was the question. So alpha is equal to what? 31. All right, moving to the next, that is question number 22. The question says an object is placed in front of, an object is placed on the principal axis of a convex lens of focal length 10 centimeter. Okay, a plane mirror is placed on the other side of the lens at a distance of 20 centimeter from the lens. The image produced by the plane mirror is 5 centimeter inside the mirror, then the distance of the object is. So basically, if this is the lens, okay, let this be the lens, and let this be the principal axis, and let this be the plane mirror. So the final image is formed at a distance of 5 centimeter from the mirror. So here this is what? 5 centimeter. So if this is the image, then the object for the mirror, O dash, that also need to be what? At a distance of 5 centimeter. Now this distance is what? 20 centimeter. So this is how much? 15 centimeter. All right. The question is the distance of the object from the lens. So we need basically this distance, which I am going to mark it as O, and U is what required. So F, what is the value of F now? As per the question, the value of F is plus 20. And what is the value of V? Please tell me, what is the value of V? Value of V is plus 50. So we need the value of what? U. And here this is lens. So 1 by V minus 1 by U equal to 1 by F. Here this is 1 upon, instead of V, we can have it as 15, all measurements are in centimeters, minus of 1 by U equal to 1 upon F is what? F is 20, isn't it? Not F is 20, F is 10. F is 10. All right, now let me take this towards the right. So here this is minus of 1 by U equals 1 by 10 minus of 1 by 15. All right, so LCM is definitely going to be 30 only. So minus of 1 by U, that is, here this is going to be 3 by 30 minus of, here this is going to be 2 by 30. All right, so here this is 3 minus 2 is minus 1, not plus 1. 3 minus 2 is 1, all divided by 30, which means the value of U is going to be what? Minus of 30. U is going to be minus of 30. That means the distance of the object from the lens is 30 centimeter. We got the value of U as minus of 30. That means in front of the mirror it is. So the distance can be marked as 30 centimeter. Moving to the next, that is question number 23. The question says, a parallel beam of monochromatic light of wavelength 5000 angstrom is incident normally on a single narrow slit of width 0.001 millimeter. The light is focused by convex lens on the screen placed on its focal plane. The first minima will be formed for an angle of diffraction of. So we all know that d times sine theta. For the first minima, that need to be what? Lambda. All right. So sine of theta, that need to be lambda divided by small letter d. Okay. Now, what's the value of lambda? Lambda is 5000 angstrom. So basically it is 5 into 10 to power 3 into 10 to the power minus of 10, all divided by small letter d is 0.001 into 10 to the power minus 3. So I can write this as 1 into 10 to the power minus 6. All right. So here this will cancel each other. This is going to be 10 to the power minus of 4, and considering this is going to be 10 to the power minus of 1. So sine theta is 5 into 10 to the power minus 1, or I can say it is 0.5, that is 1 by 2. So definitely theta is going to be what? 30 degree. All right. Moving to the next, that is question number 24. Question number 24 says, two waves of intensity ratio 1 by 9 cross each other at a point. The resultant intensity is at the point when option A, waves are incoherent is I1, option B, when they are coherent is I2, and different phase by 60 degree. If I1 by I2 equal to 10 by x, then what is the value of x? All right. So as per the question, I1 by I2, that's equal to what? 9. I1 by I2 is equal to 9. Or I can say I1, that's equal to 9 times I2. Okay, fine, 9 times I2. So if the case number 1, they are incoherent. So in that first case, that means I suffix A, once they are incoherent, the intensity is going to be what? I1 plus I2. Individual intensities they are going to be. So I1 is 9 times I2, isn't it? And I2, I am marking it as I2 only. I1 is 9 times I2, and I2 I am marking it as I2 only. So here this is 10 times I2. Once it is incoherent, and once they are coherent, that means I suffix B, there it need to be what? I1 plus I2 plus 2 under root of I1 I2 into cos of phi. All right. So I1 is 9 times I2 plus here we have got I2 plus 2 into, again I1 is 9 times I2, okay, into I2, and cos phi is cos 60 is 1 by 2. This 2 and 2 will cancel each other. So 9 I2 plus I2, that is 10 times I2. All right. And here we have got what? 3 times I2. So basically this is 13 times I2. So I suffix B is coming as what? 13 times I2. All right. Now we need the ratio of what? IA by IB. IA by IB. What was IA? IA was 10 times I2 and IB was 13 times I2. I2 and I2 will cancel each other. So we are going to get this as what? 10 by 13. And here it is 10 by x. As per the question, that is 10 by x. So the value of x is going to be what? 30. All right, moving to the next, that is question number 25. Question number 25 says, two streams of photons possessing energies equal to twice and 10 times the work function of metal are incident on metal surface successively. All right. So the energy of the first photon, that is 2 times 5, and the energy of the second one, that is 10 times 5. Okay, the value of ratio of maximum kinetic energy of the photons emitted in two cases is x is to y, then the value of x is. So the kinetic energy for case 1, that need to be equal to what? That need to be equal to energy of the incident radiation, that means 2 times 5 minus of work function. And kinetic energy in case of the second one, that need to be 10 times 5 minus of 5. Okay, and here this need to be what? Half of m into v1 square, and here this need to be half of m into v2 square. So I can now consider these two equations. 2 times minus 5 is 2 times 5 minus of 5 is 5 upon 10 times 5 minus of 5 is 9 times 5, and here this is equal to v1 square upon v2 square. 5 and 5 will cancel each other. which means this is equal to 1 by 9. All right. So while taking the ratio V1 by V2, V1 square by V2 square is 1 by 9. So V1 by V2, that need to be what? 1 by 3. And here this is equal to x upon y, which means the value of x that need to be equal to 1. So that was all from the in-depth discussion of physics from JEE Mantra 2025 series. We will meet you soon with the detailed discussion of another test. Till then, take care and bye-bye.
Hi dears, welcome to Brilliant Qatar JEE Mantra Chemistry Part Test 3 Question Answer Discussion. In this Part Test 3, you already faced the question from the chapters Coordination Compounds, Haloalkanes, Haloarenes and Amines. Hope the exams was very well. So, let's check the questions and the detailed solution. Are you ready? Yes. So, dears, this was the first question. Which of the following compounds shows optical isomerism? While we were discussing about the recap video, we explained detailedly about this isomerism regarding structural isomerism as well as the stereoisomerism. In that, about optical isomerism, I told you already, you watched that video, I hope so. What? You watched that. In that optical isomerism, if any compound is showing optical isomerism in coordination compounds, the minimum criteria is there should not be any symmetry. There should not be any symmetry. That is mainly possible by that is mainly possessed by the central metal atom. Along with that, the ligands are coming. That ligands are bidentate or polydentate. So here we can, while we are looking here, it is all are same type. CuNH3 4. All ammonia molecules. All are ammonia. Here all are chlorine. All the ligands are chlorine, same. Here all the ligands are cyanide 6 times, but all are monodentate. What about this one? C2O4 3. C2O4 means oxalato. Oxalato. This is actually of the type of MAA thrice. MAA thrice. That can show what? Optical activity. So our answer is what? Option D. Okay, ready? Keep it in mind. See. Next question, second question. What about the second question? Which of the following system has maximum number of unpaired electrons? Maximum number of unpaired electrons. What about the first one? D4 octahedral. Octahedral means T2G, EG. Like that only they are going to split. They are low spin. Low spin means pairing will be taking place. So in T2G, total 4 are there. So T2G 4, EG 0. That means T2G means we can represent like this. You can easily understand like this. See, T2G means 3 orbitals are there. EG means 0. Okay. Here once we are drawing like this, in T2G, 1, 2, 3, 4. Because it is low spin, pairing will take place. Okay. So how many unpaired electrons are there? Unpaired electrons is equal to, number of unpaired electrons is equal to 2. Ready? What about the second one? D6 tetrahedral high spin. So that means I will draw like this. See, you can see. 1, 2, 3, T2G and EG. Okay, T2G and EG. Here 6 electrons are there. So 1, 2, 3 and it is high spin. High spin means no pairing. The fourth electron will go to top and fifth electron will be here. Then only pairing will take place. So now how many unpaired electrons are there? 1, 2, 3, 4 unpaired electrons are there. Second option, okay, D6. And what about the third option here? D6 octahedral low spin. D6 octahedral low spin means you can see here 1, 2, 3 and D6 low spin means what? Pairing will take place initially. So 3, 4, 5, 6. So N equal to how much? 0. And D9 means what? D9 octahedral means what? D9 octahedral you can draw like this. See 1, 2, 3, 4, 5. Okay, this is T2G. This is EG. And in the case of D9 octahedral, if it is high spin or low spin, it will be like this 1, 2, 3, 4, 5, 6, 7, 8, 9. The high spin or low spin, same number of unpaired equal to 1. So our question is, in our question, they are asking maximum number of unpaired electrons is possible in here 2, here 4, here 0, the next one 1. So answer is what? D6 tetrahedral high spin. D6 tetrahedral high spin. Clear? Ready? Yeah. Next question. What about the next question? See, next question. If delta O, that means crystal field splitting energy of octahedral complex, for the complex COCl6 3-, Okay, COCl6 3 minus. Here coordination number is 6, so that is octahedral splitting. Is 18,000 centimeter inverse. Then what is the delta T? Tetrahedral crystal field splitting energy. Okay, for the complex. Same ligand we are taking, but 4, okay. COCl6 2 minus is. So we know the relation. We know the relation. What's the relation? Delta T equal to 4 by 9 times delta O. Delta T equal to 4 by 9 times delta O. So 4 by 9 into delta O, how much? Delta O is 18,000. 18,000. So we can cancel 9 and 18,000. We can cancel 2,000. So 4 into 2,000, 8,000. 8,000 centimeter inverse. Option C will come. Ready, guys? All the questions are easy. All the questions are easy. I hope you did it well. Okay, yeah, see. Next question. What about next question? While we were doing the recap video, I so many times I told carbonyls. From carbonyls question was there. Okay, especially we show the videos of what? We show the diagrams of what? That different types of metal carbonyl. If you didn't attend that question, means you just go and watch that video one more time. Okay, so see here the number of bridging carbon monoxide ligand and cobalt bonds in CO twice CO8. So that means cobalt, 2 cobalts are there. Okay, you can see 2 cobalts are there along with how many carbon monoxide? 8 carbon monoxide. 1 carbon monoxide is this one. C triple bond O, another C triple bond O, another C triple bond CO. 3 CO are there. Here also 3 CO are there. This is a structure, okay. 3 CO are there, you can see. And 1 CO is connecting like this, okay. And another CO is connecting like this. And in between cobalt, 1 bond. So now you can see how many carbon monoxide bridges are there. They are asking carbon monoxide ligand bridge. Bridging carbon monoxide ligand. 1 and 2. 2 are there. Then how many cobalt bond is there? That is 1. So 2 carbon monoxide bridging ligand and 1 cobalt bond. So 2 and 1 is the correct answer. Option A. Ready? Clear? Yeah. We can move to the next question. What's the question here? Pick out the correct statement with respect to MnCN6 3 minus. It is related to valence bond theory. So MnCN6 3 minus. Then the question is, it is sp3d2 hybridized and octahedral. It is sp3d2 hybridized and tetrahedral. It is d2sp3 hybridized and octahedral. It is dsp2 hybridized and square planar. From that itself, we can remove 2 options. Which options? This is actually, you can see here the coordination number is 6. So that is octahedral only possible. So here square planar, that we can remove. And sp3d2 hybridized and tetrahedral, that also we can remove. Either A or C. So we can check it. MnCN6 3 minus. See, MnCN6, okay, CN6 3 minus, okay. Here central metal atom is manganese. Manganese atomic number is 25. Electronic configuration argon 4s2 3d5. Ready, guys? Correct? Yeah. But in this case, central metal atom charge is 3 plus. Manganese charge is 3 plus. Manganese 3 plus means how many electrons only there in remaining? Argon 4s2 is leaving, and from 3d 1 is leaving, and then 3d 4. So their ground state I can draw. Ground state we can draw 3d. 3d orbital means 5 orbitals are there in 3d subshell. So 1, 2, 3, 4 electrons are there in 3d. Then after that 4s is there. After that 4p is there. This is the ground state. This is the ground state of Mn3 plus. So towards this Mn3 plus only who is coming for bonding? Cn minus. How many Cn minus are coming? 6 Cn minus are coming. That time this manganese become excited. Okay, that will go to excited state. So how their excitement we can show, how we can, only one pairing will take place, remaining 2 unpaired. Okay, remaining 1, 2, 3, 4, 5. Okay, remaining 2 unpaired will be there. 1 electron will be paired. Then S will be there. Here 3p will be there. You can see 4s and here it is 4p. Now which all are the orbital will undergo intermixing? 6 cyanide is coming. So 6 vacant orbitals are required. 1, 2, 3, 4, 5, 6. So 2d, that is d2. Then 1s, then s, then 3p. So d2sp3, that means which hybridization? D2sp3 means which shape? Octahedral. Octahedral. So what's the answer? It is D2sp3 hybridized and octahedral. So you have to keep it in mind. It is a kind of exception here. Only one is pairing. Okay, cyanide is strong field ligand even though one is pairing. Not two are not pairing. If two are not pairing means we didn't learn such a kind of hybridization. D3sp2 we didn't learn. Okay, so only possibility is D2sp3. Okay, keep it in the mind. So we can go to the next question. This is the next question. What's the question here? In the complexes FeH2O6 3 plus, FeCN6 3 minus, FeC2O4 3 minus, okay, and FeCl6 3 minus, more stability. Stability mainly depends on the charge of cation, charge of anion, and chelation. Here the cation is same. Fe is same only. Okay, Fe same only. Fe only. Then here once we are looking to the Fe3 plus, Fe3 plus, Fe3 plus, Fe3 plus only. Next, along with that ligand H2O, cyanide, C2O4 and Cl6. Didentate or polydentate means they can have a ability to form what? Chelation. Chelation increases what? Stability. Then what's the answer? FeC2O4 thrice, only oxalate, only what? Didentate. Remaining cyanide, water and Cl, all are monodentate. So what's the answer? B. How much time took to answer that question? 1 second. Yeah, this kind of questions will be there. That time you have to answer it easily. Ready? Yeah. So answer is what? B. Next question. John Teller effect is not observed in high spin complexes of. This John Teller defect only occur in which type of complexes? The complexes, I mean especially in octahedral complexes, which has unsymmetric distribution of electrons in T2G and EG. Unsymmetrically, electrons are distributed in T2G and EG. Then in the case of octahedral complexes, their axial length as well as equatorial length will be not equal. That is what is called John Teller effect, that you know. So let's check in which case T2G and EG electrons are not symmetrically distributed. Not symmetrically distributed means John Teller defect is there. Symmetrically distributed means no John Teller defect. Clear or not? Yeah. Yes. Okay, see, first one, D4. So this is only applicable to what? Octahedral complexes. So octahedral means that d orbitals are splitting it into T2G and EG. Okay, this is T2G, the bottom one is T2G, upper one is EG. That you know, that all are the basic idea you know. D4 means what? D4 means how I can write. So this is all are discussed for high spin. High spin means no pairing initially. 1, 2, 3, 4. So see, here you can see, this is symmetric. Each orbital contain 1, 1, 1, symmetric. This one is not symmetric. Two degenerate orbitals are there in EG, but one contain 1 electron, one contain no electron. So it is asymmetric. So net asymmetric. Here John Teller defect is there. John Teller defect is there. Okay, John Teller defect is there. John Teller defect is there. Okay, because asymmetry is there. John Teller defect is there. In our question, not observed. John Teller defect is not observed. So here, length of axial bond as well as length of equatorial bond are not equal. Okay, length of axial not equal to length of equatorial. That's the thing. In the case of generally octahedral, length of axial and length of equatorial are same. But John Teller defect is there means both are not equal. That's what is John Teller defect. You know the idea. Okay, yeah, I'm not wasting my time to explain the theory again. You know the basic ideas. Ready? Yes or no? Yeah. Okay. So next one, D9. D9 means what? Again, we are having what? That is high spin. If it is high spin or low spin, D9 is same only. T2G, EG, 1, 2, 3. Okay. Then 4, then 5. Because high spin first like that only filled. Then only pairing. 6, 7, 8, 9. Here also you can see this each orbital in T2G are 2, 2, 2, 2. So that is symmetric. This one is not symmetric. First one containing in EG, one orbital contain 2 electron, another orbital contain only 1 electron. They are not symmetric. Symmetric means either all contain no electron, or all contain 1 electron, or all contain 2 electron. All should be same. Here they are not same. So asymmetry is there. So that's why John Teller defect is there. Okay, length of axial is not equal to length of equatorial. This tick means John Taylor defect is there. Okay, then what about D7? D7 high spin. See, D7 high spin. D7 high spin means T2G is this one. This is EG. D7 high spin means 1, 2, 3, 4, 5, 6, 7. Once we are looking this one, here also what is there? Here also you can see asymmetry is there. First two contain 2, 2. Then third one contain only 1. So asymmetry is there. Here symmetric only. Anyhow the net molecule is what? Asymmetric. Net orbital configuration is asymmetric. That's why John Taylor defect is there. What about D8 high spin? D8 high spin. See D8 high spin. Once we are writing, we can write like this. This is T2G. This is EG. So how many electrons we are having? 8 electrons we are having. 1, 2, 3. High spin means 4, 5. Okay. Then only pairing. 6, 7, 8. Yes. Here symmetry is there. T2G orbital. T2G 3 orbitals are there. Each containing 2, 2, 2, 2. That means they are symmetric. They are symmetric. All are same. And EG contain 2 orbitals contain 1, 1, 1. They are also symmetric. So symmetry is there. Here there is no John Taylor defect. That means length of axial equal to length of equatorial in this case. So what's the answer for our question? Option D is the correct answer. Clear guys? Yeah. So we can go to the next question. This is the question. This question actually comes from which chapter? Haloalkane, haloarenes. What's the question here? The compound which undergo SN1 reaction most readily. SN1 means substitution nucleophilic unimolecular reaction. In SN1 reaction that possess through carbocation mechanism, 2 steps reaction. So if it is most readily means the carbocation should be more stable. So we have to check the carbocation. How we will check the carbocation? I have to remove this Br and I have to put 1 plus here. I have to remove this Br and I have to put 1 plus here. I have to remove this Br and I have to put 1 plus here. I have to remove this Br and I have to put 1 plus here. Out of that, which carbocation is more stable? That will give SN1 more steadily. What about this one? This is secondary carbocation. What about this one? This is primary carbocation, but it can shift to here. So it can give you what? Tertiary carbocation. Okay. What about this? See, what about this one? This is actually tertiary carbocation, but here what is the problem? Here this plus charge is coming at the bridge head bicyclic compound. According to Brett's rule, that is not stable. This one allylic carbocation. So which is stable here? So allylic carbocation is stable here. So option B is the correct answer. What's the answer? Option B is the correct answer. Which one most readily is what? Option B. Ready? Yes, we can go to the next one. What's the next question? The major product in the following reaction. This is also related to haloalkanes and haloarenes. They given one compound that you are treating with the bromine in presence of FeBr3. Bromine in presence of FeBr3 that will undergo heterolytic fission. Automatically that is electrophilic substitution reaction. What reaction? Electrophilic substitution reaction. So I will show that one. I will draw that one here. You can see. This is easy. Okay. See this benzene ring that connected with the C double bond O. Okay. Then another benzene ring is there. That is connecting with the CH2. Okay. CH2. Here another benzene ring is there. That only you are treating with the bromine and FeBr3. So once you are treating with the bromine and FeBr3, that Br plus is going to substitute in that benzene ring. That is electrophilic substitution. Towards where it can go? The C double bond or double bonded functional group attached benzene ring is always deactivating group. That double bonded functional groups are always double bonded or triple bond. Unsaturation containing functional group attached to benzene ring is metadirective or deactivating. What about CH2? They show plus hyperconjugation. So that is ortho-para-directive. So which is activating group? That ortho-para-directive group is activating group. So this CH2 attached to benzene ring, towards that only bromine will go. That will go towards where? The para portion of that CH2. Why it is not going to here? This CO attached to benzene ring is deactivating group. So that is metadirective. Metadirective means deactivating. So more activating is ortho-para. That is actually plus R effective, or else here it is plus H effective. Positive hyperconjugation showing group is methyl group. Okay, so that attached. So towards where only it will go? Para portion. Why it is not going to ortho portion? Ortho portion is because of steric hindrance. It will prefer what? The para portion. So what's the answer here? Once we are looking towards the CH2 attached to benzene ring, it's para portion only it will go. So answer is what? Option B is the correct answer. Option B is the correct answer. Ready guys? Ready? Yeah. We can go to the next question. What about the question here? They given C6H5CH, double bond CH2 plus HBr. See, C6H5, okay, C6H5CH, double bond CH2 plus HBr. So this is actually what? This is actually what? Marconic of addition. First, initially, H plus will go and attach with more number of carbon containing hydrogen. So here it will go and attach. Br will go and attach here. If hydrogen is going and attaching here, means here plus charge will come. Yes, benzylic carbocation we will get. Through the stable carbocation mechanism, only Marconic of rule will follow. So that plus will go and attach here. So what we will get? C6H5CH, double bond. That double bond will break. Then CH2. Here one more H will go and attach. So CH3. Here only which one will go and attach? Br will go and attach. Br will go and attach. So that is Marconic of addition carbocation mechanism. Ready? Then same thing. Second thing they given. See, para-ethyl aniline. Para-ethyl aniline they given. You can see para-ethyl aniline. Okay. Para-ethyl aniline. Here also you can see, guys. Here aniline. Okay. NH2. And this is ethyl group, CH2, CH3, that you are treating with what? Bromine in presence of UV light. Bromine in presence of UV light means, or else heat means, bromine in presence of UV light or heat. That means what? Delta means heat. Means what? That will give free radical substitution. Where this free radical will go and substitute, that also follows what? That also follows tertiary carbocation or benzylic free radical is more stable. So, where only it will go and substitute this bromine. Bromine will go and substitute the benzylic carbon. So where you can see here, this is the one. Here NH2 is there. Here this CH, here CH3. This is benzylic carbon. There only which one will go and substitute. That H only this Br will go and substitute. So here you can see this also Br will go and substitute in benzylic carbon. Here also benzylic carbon, only bromine. Here this is carbocation mechanism. This is free radical mechanism. So what's our answer? Once we are looking, what's our answer? So benzylic carbon, bromine is attaching. Benzylic carbon, bromine is attaching. So option B is the correct answer. Okay guys, ready? Yes. We can move to the next question. This question again related to optical activity. What about the question? Which of the following biphenyl is optically active? You know, all in benzene ring, all the carbon are in sp2 hybridized. Actually, they are in both benzene are in same plane. Both benzene are in same plane. But here you see in option B, once you are looking, here iodine, bromine. Okay. So let me show you. This is the structure actually. This is the structure. Okay. Here you can see this one is bromine. This one is what? Iodine. But once they are coming in the same plane means because of the steric hindrance, they will try to rotate. Now they belongs to different plane. Initially they are in same plane, but once they start to rotate means what will happen? They will be in different plane. Because of what? Because of iodine comes nearby, bromine comes nearby means that benzene ring is not in same plane. Okay, they will try to rotate to avoid the repulsion. So they are having no symmetry. So they will show what? Optical activity. The main thing for optical activity is what? Main thing for optical activity is asymmetry is required. They should not be in same plane. So what's the answer? B. Ready? See. Next one. What about the next question? The major product of the following reaction is, you can see AlCl3 anhydrous in H2O. That time itself you have to remember what? That is what kind of reaction? That is carbocation mechanism is going to occur. What kind of reaction? Carbocation mechanism is going to occur. Okay. So here you can see they given one compound. I'm drawing that compound here again. You can see. I'm drawing that compound again. Here you can see OCH3 is there. Okay, here OCH3. Okay, here OCH3 is there. OCH3. Then here 1, 2, 3, 4 carbon. Okay, 4 carbon here. So 1, 2, 3. The fourth carbon here CH3. Okay, and here one branch is there. Correct. Here one branch is there. 1, 2, 3, 4. CH2Cl and one branch. Okay, I'm sorry. Here CH2Cl and one branch. Okay, CH2Cl and one branch. Now, once you are treating with the AlCl3, that AlCl3 will break here. This one, it will break here. The CH2Cl that will break. Okay, CH2Cl that will break heterolytically. That means this Cl will take the electron towards it. that becomes Cl minus, this portion become plus. I am drawing that one again. You can understand. See, listen. Here benzene ring, here OCH3, okay, OCH3, 1, 2, 3, 4, okay, here CH2, this become plus, here one methyl group is there. So this Cl minus will go along with what? This Cl minus will go along with AlCl3 and it will be forming AlCl4 minus. Now that become carbocation. Now what will happen? This carbocation is primary carbocation. There is a possibility of rearrangement. Here you can see, here in this carbon already one CH3 group is there. Here CH2, here CH2 is there. Here one more hydrogen is there. This hydrogen will shift to here. That is what is called 1,2 hydrate shift. What shift? That is what is called 1,2 hydrate shift. You can see guys. See, you can see 1,2 hydrate shift. I am writing 1,2 hydrate shift. Okay, 1,2 hydrate shift. So 1,2 hydrate shift taking place means what will happen? You can see, benzene ring is there. Here OCH3 is there. Okay, here OCH3 is there. OCH3 is there. Here 1, 2, 3. Okay, 1, 2, 3 and 4. So in third carbon here one methyl group is there. Here plus charge will come. That H will shift to here. That becomes CH3. Now what will happen? This one from here one hydrogen will be eliminated. Okay, from here one hydrogen will be that hydrogen will go out. So this one and this one will go and attach. This one and this one will go and attach. How they will go and attach? See. How they will go and attach. You can see how they will go and attach. That will go and attach. So that time they will form a ring. See, here benzene ring. Here benzene ring. Here OCH3. See, OCH3. Here you can see 1, 2, 3. Okay, and 4. 1, 2, 3. Okay, 1, 2, 3. So I'm drawing 1 here, 2 here, 3 here. 1, 2, 3. 1, 2, 3. 1, 2, 3. And along with that 3, third carbon, 2 methyl groups are there. Here that plus charge is there. So that one and this one will connect. So this is your answer. Once you are hydrolyzing, this is your answer. Okay. So here methyl group will come. That will form a ring. Okay. So what's the answer for that in our question? The answer is what? Option D is the correct answer. Ready guys? Yeah. We can go to the next idea. This is the next question. The increasing order of reactivity of the following compound is for SN1. Again SN1. SN1 means what? Carbocation mechanism. So here I can remove this Cl. So that time it will become CH2 plus. I can remove this Cl. This will become plus carbocation. I can remove this Cl. Here it will become plus. I can remove this Cl. It will become plus. Now out of this, which carbocation is stable? This is benzylic carbocation. Here in benzylic carbocation, in para portion CH3, OCH3 is there. That's OCH3. Okay. This is OCH3 is there. OCH3 is what? Electron donating group. Whenever electron is donating, this will be through resonance, this will become more stable. So out of this, which is more stable? C is more stable. Which is more stable? C is more stable. C is more stable. Okay, C is more stable. After that, which one will come? D, because benzylic is more stable. D will come. Two options are D is more stable. After that, which is more stable? A, because this can shift to here. That will become tertiary carbocation. Tertiary carbocation is more stable. A. After that, which is stable? After that, A is stable. After that, which is stable? B is stable. So option C is the correct answer. Only the stability of what? Carbocation. Ready? Yeah. We can move to the next question. Question number 14. Correct order of basic strength. In the case of amines, we know that the basic strength is mainly because of what? The nitrogen containing lone pair. In everywhere, see, this is aniline. Here lone pair is there. Here lone pair is there. Here lone pair is there. Okay. Here also lone pair is there. In which case they can donate lone pair very easily? Aliphatic amine. Which is aliphatic amine? Second one is aliphatic amine. Second one is because that aniline is not that amine group is not directly attached to benzene ring, so there is no resonance there. So that electrons are easily donatable. But here in aniline, this NH2 attached to benzene ring, that lone pair is not easily donatable. So that can be utilized for the resonance. So that's why electron density is less on nitrogen. So acid basicity is less. Ready? What about here? Here also lone pair is taking for resonance, but here two CH3 groups are there. CH3 groups are electron donating group. So electron density is more compared to aniline. What about here? This aniline, in this aniline OCH3 is there, but OCH3 at meta position. Meta position means they are withdrawing, minus I effect. They are withdrawing. Automatically, its electron density is less than that of aniline. Less than that of aniline. So which one will be having more electron density? That is for second one. Second one is more electron denser. So second one. After that, which one will come? Third one. Third one. After that, first one. After that, fourth one. Option B is the correct answer. Only comparison. You can do it. Yes or no? Yeah. We can go to the next question. Question number 15. Phenol is there that you are treating with benzene diazonium chloride. In basic medium, major product will be. So that idea you learned. See, this is phenol. This is phenol, guys. This is phenol. Okay. That phenol you are treating with what? You are treating with what? You are treating with benzene diazonium chloride. Cl minus N2 plus. Okay. And phenyl group. What is happening here? In basic medium, here H is there. This H and Cl will go. Okay. Then in basic medium, KOH medium, then what is remaining there? You know, that is actually called coupling reaction. Here OH will be there. Then benzene ring. Then N double bond Na. Then what? Benzene ring. This is para hydroxyazobenzene. Para hydroxyazobenzene. Okay, that is a orange dye. Orange dye. You learned this idea. Okay, this is actually called a coupling reaction. So what's the answer? Para hydroxyazobenzene. Option B is the correct answer. Ready, guys? Yeah. We can move to the next question. What's the question here? The structure of compound formed when nitrobenzene. I am putting one star here. It's very important. Nitrobenzene is reduced by lithium aluminum hydride. Nitrobenzene. This is nitrobenzene. Okay. Nitrobenzene. That is reduced by lithium aluminum hydride. Don't write aniline. Don't write aniline. In the case of aromatic nitro compounds, lithium aluminum hydride, if you are using, means you will get azobenzene. You will get what? Benzene, N double bond N and benzene. Azobenzene you will get. But if you are taking normal aliphatic NO2, normal aliphatic nitro compound, aliphatic CH3NO2 you are taking, and you are treating with lithium aluminum hydride, that time you will get what? RNH2. Aliphatic means amine, and if it is aromatic means what? Azobenzene you will get. So what's the answer? Option C is the correct answer. Keep it in mind. Don't fall in such a kind of things. If they are giving means don't fall there. Okay, ready? Yeah, my children won't go and fall. Okay, I know that. I trust you guys. Okay, see, next question. What about the next question here? A given nitrogen containing aromatic compound, A react with SN and HCl followed by HNO2 to give unstable compound B. So one compound A that react with SN bar HCl then followed by HNO2. Of course, here it is reduction. SN bar HCl is reduction. Something on reduction, then HNO2 means that is actually aniline. Aniline you will get. After reduction you will get aniline. So the compound A should be what? The compound A should be nitrobenzene, correct? Nitrobenzene. Nitrobenzene. Compound A should be nitrobenzene. That on reaction with the SN bar HCl. Reduction, what you will get? What you will get? Tell me. What you will get? This is, you will get aniline. You will get aniline. Okay. This aniline you are treating with what? HNO2, nitrous acid at 0 degrees Celsius to 5 degrees Celsius. That is what is called diazotization. Benzene diazonium chloride. Correct? That's a statement they are giving. Benzene diazonium chloride. After that, that is B. You are getting a compound B. This B on treatment with phenol forms a beautiful colored compound. That only we did in the previous question. This B you are treating with the phenol. Phenol. You are treating with the phenol. You will get what? Para hydroxyazobenzene. You will get para hydroxyazobenzene. It is a orange colored dye. It is a orange colored dye. Beautiful colored compound. Okay. Yeah. So they are telling that one. Then C. With the molecular formula C12H10N2O. The structure compound A is. This is actually C. The structure compound A is. A is what? Nitrobenzene. Simple. A is nitrobenzene. So what's the answer? Option B. Ready, guys? Hope you are doing. Yes or no? Yeah, I can see. Okay, see. Next question. This is the next question. Canonical structures of anilinium ion obtained by accepting a proton are given below. Choose the correct statements. They given the anilinium ions canonical forms. Actually, anilinium ion itself is unstable because aniline is more stable than anilinium ion. Even though in high acidic condition, that aniline will force it to gain that proton. So then they will form anilinium ion. They are giving the anilinium ion structures. Out of that, which all are the stable one, which is the correct statement. They are giving anilinium ion has two stable canonical structure, 1 and 3. Yes, that statement is correct. 1 and 3 are stable structure. 2 is not stable because in 2 you can see here benzene is there. Okay, benzene, not benzene. This ring is there here along with the double bond N. Here H. Around this nitrogen, you can see around this nitrogen, how many bonds are there? 5 bonds are coming. Total 10 electrons are there. According to resonance concepts, a octet containing around atom, octet electron should be there. That's a more stable one. So this is unstable. This nitrogen around it, how many are coming? 10 electrons are coming. 2 is unstable. So what's the answer? Option A is the correct answer. Hope you got it. Ready? You just go through the remaining. Not correct. Okay. See, next one. What about next one? Which of the following reactions will not give primary amine? What about option A? CH3, C double bond O, NH2. That you are treating with alcoholic KOH and bromine. This is what is called a Hofmann bromamide degradation reaction. So this CO we will eliminate, NH2 we will connect, CH3 NH2, you will get amine. It is a primary amine, Hofmann bromamide degradation reaction. You remember? Yeah, you remember, I know. Then second one, CH3CN, cyanide compound, cyano compound on reduction, lithium aluminium hydrate. Yes, here also what will happen? It will give you CH3, CH2, NH2. CH3, CH2, NH2. That also primary amine. What about the third case? CH3NC. Isocyanate. That you are treating with lithium aluminium hydrate. Yeah. Here the answer is what? CH3, NH, CH3. This is what? This is secondary amine. This is secondary amine. What about the third one? What about the fourth one? Here also you can see CH3, CONH2 with lithium aluminium hydrate. That time also answer is what? That time also answer is CH3, CH2, NH2. There is no reduction in the carbon. Same number of carbon containing amine. That also primary amine. So only secondary amine is getting in which case? The CH3NC. Isocyanate you are taking. Answer is C. Ready? Yeah, I know that you did it. Correct na guys? Yes or no? Yeah. Okay, I can hear your voice. Okay, I can hear your inner voice. Yes. Okay. The 20th question, 20th MCQ question. What's the question? Which of the following amines does not react with the Hinsberg reagent? Hinsberg reagent will react with the primary amine and form a compound. That compound contain acidic hydrogen that will be soluble in alkali. We know. Secondary amine also will react, but that is insoluble in alkali. But tertiary amine does not react with the Hinsberg reagent. So out of this, which is tertiary amine? This is primary amine. This one secondary amine. This one tertiary amine. So answer is what? C. C does not react with the Hinsberg reagent. That's all about the 20 MCQ question. I hope you did it well. Yes or no, guys? Dears, next we have to look the integer type questions. Hope this questions also went well. Ready? Yeah. So here it is the first question. The number of unpaired electrons in NiCO4 is a tetracarbonyl nickel. You know, tetracarbonyl nickel. Okay, tetracarbonyl nickel. Here the central atom is nickel. Atomic number is 28. Electronic configuration argon 4s2 3d8. Okay. Ground state. What about ground state? 3D contain 8 electron, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. And here 4s is there. Okay, 4s contain how many? This is 3D. 4s contain 2 electron. And at excited state, whenever carbon monoxide is approaching, that will undergo excitement. During excitation, carbon monoxide is a strong field ligand. Pairing will take place. 2, 4, 6. This will pair, as well as this 4s electron also will shift it to 3D. Okay, that will be shifted to 3D. Then here you can see this 4s and 4p. That will form what? sp3 hybridization. That idea you know. Anyhow, here how many unpaired electrons are there? 0 unpaired electrons are there. So 0 is the answer. How many unpaired electrons are there? 0 unpaired electrons are there. Correct? Yeah. We can go to the next question. What about the next question? The stability constant for one reaction. They given stability constant K equal to what? 5 into 10 raised to 5. Now they are asking the instability constant. Instability constant means what? Instability constant means what? Instability constant is equal to 1 by stability constant. Reciprocal of stability constant 1 by 5 into 10 raised to 5. 1 by 5 into 10 raised to 5 means 1 by 5 into 10 raised to minus 5. That means 10 by 5 into 10 raised to minus 6. That means 2 into 10 raised to minus 6. They are asking is of the type of x into 10 raised to minus 6. Then the value of x is how much? X is equal to 2. X is equal to 2. Ready? Simple one. Ready? Easily you can answer it. Correct? Yeah. Next, third question. What's the third question? The number of different types of alkene obtained by the reaction of 2-bromobutane with C2H5ONO. 2-bromobutane means what? 2-bromobutane means this one. CH3, CHBr. Okay, CH2, CH3. This is 2-bromobutane. This one you are treating with what? C2H5ONA. C2H5ONA. In presence of a base and alcohol, C2H5OH. What kind of reaction will take place? Elimination reaction will take place. What about elimination? Beta elimination. So this one, bromine attached carbon is alpha. This is beta. This is beta. So how many beta? How many alpha? How many beta elimination will take place? From here one alpha. From here one beta. One will be going. One double bond will be forming there. So we can write what? CH3, CH2. Double bond CH, single bond CH2, CH3. So this is but 1 in 1 product. Okay, but 1 in 1 product. One more product possibility is from here alpha, from here beta, one hydrogen will go in between that. From here alpha halogen, from beta hydrogen, in between alpha and beta double bond. So what you will get? See, CH3, CH, double bond CH. Okay, here CH3. This is but 2-ene you will get. But 2-ene you will get. So you are getting 2 out of that. But 2-ene is the major product according to size of fruit. But this but 2-ene may be either cis or trans. But 2-ene means that may be either